Students may not know me. I'm M. Srinivasan, formerly from the Baba Atomic Research Center.
Yeah.
I was involved in cold fusion from day one, 1989. Of course, I'm now retired from BAT, but I am sort of keeping in touch with this. I met Bob at the last conference in Japan.
Regretted it ever since.
And we discussed the possibility of his coming and giving a talk here because he said he's coming to India. So that's it, he's here and we look forward to it.
Which is just about to start. Good.
Okay, I am Kannan Iyer from the Department of Mechanical Engineering. I generally work in the area of heat transfer and fluid flow applied to nuclear reactors. And we have just taken up a project on this area now. As Prathamesh said, we have just made a beginning. We hope we succeed.
Okay. Right. Record. Testing. There we go. Excellent. Okay, so the first person I want to talk about, well, just before that, in May, everything we do in the MFMP is published online. So the Martin Fleischmann Memorial Project was set up at ICCF 17 in Daejeon in South Korea. 3 weeks after Martin Fleischmann sadly passed on. He was one of the guys that I really wanted to meet. I had actually seen the original announcement. I was studying science and I'd read back-to-back New Sciences for years, and I desperately wanted to meet him, so I managed to go there. Unfortunately, he passed away and it was just bad timing, I guess. Anyway, so I went there a couple of days in. It was very clear that there was some real science going on, but what was also clear is that the people that were doing the science were passing away, and that those that were reaching some level of success, someone would come in with some money and take them off the table. And this is what would happen to the other person I really wanted to meet there, was Francesco Piatelli. He was taken off the table. He decided just a few days before not to turn up. So that was disappointing. Anyway, came away, we set up the project, myself and 4 other guys that were there, with a view to either finding someone to replicate or doing it ourselves, but in order to do it openly on the web, enable people to learn, lose their fear about doing it, and also to stimulate others to research into the field. So it wasn't necessary that we actually did it, maybe we just get close and someone else has to throw their cards on the table. So it's a catalytic process in itself. Anyway, that's the brief introduction there. In January 22nd, 2013, we'd already, but the key person was Francesco Celani. He'd done a Constantan wire, it's a treated wire, it's dual heated. They put it in air, it heats up, and as it heats up, it gets oxidized on the outside and it cools down. It heats up, cools down, heats up. And what happens is the oxides like concertina up, like one of those, French instruments. Harpsichord, is it? Harpsichord? Harmonica? No, it's one of those. Harpsichord, I think. Yeah, and it concertinas up, and then he reduces that, and it creates a nanoporous structure on the surface that's connected to a wire. It's quite an elegant system because you can actually pass current directly through the so-called active environment. You put that into a calorimeter. Everyone criticized his calorimeter, but they didn't see why it was generated. He used to have a mass flow calorimeter, which was super fancy and everything. He'd prepare these wires, put them in there, and wonder why there was nothing going on, and then he'd open it up and find all of the active material had fallen off the wire. So he designed this as an inspection tool, so he could see the wire under the reaction, the stress conditions, to establish which processes left the wire intact during its active run. And it just became a useful tool. And we learnt the first valuable lesson. To be fair, he wanted to do this as well. So he used borosilicate glass, and that melted at 350 degrees. Not melted, but started to soften around 300 degrees. So he was going to go to quartz, and we thought we'd leapfrog him when we started doing the replication. So he's very brave to allow us to do it. And we built our first reactor with quartz, and we didn't see any excess heat. We built our second reactor with quartz, we didn't see any excess heat. But Mathieu Vallat in France decided to build it as an exact replication as much as possible, and ordered borosilicate. And we started the experiment in California time 12 seconds past 12 minutes past 12 on the 12th of the 12th of the 12th. We had to have that date, otherwise you would have to wait 1,000 years to get some, no, you wouldn't, like 10,000 years, right? Anyway, a long time, and I was actually in Cochin in India. It was the middle of the night, because it's 11 and a half hours sync with California. So I didn't sleep that day, and this is a pattern I have working in Lena, so bear that in mind. Anyway, so 2 days later I was in Rome, and we were presenting our results. We apparently saw 12.5% excess heat, and this is the problem in this field, and maybe other people will experience this or have experienced it. Once you see some excess heat, you're hooked. And it's like, oh no, okay, now I have to look further. So when I came out of that conference room, having given our presentations and talked about the MFMP, I heard these footsteps come up behind me, big burly sounding stomps, and this guy tapped on my shoulder, and I turned around. There was this big, it was in an Italian military base, like officers' kind of apartments and stuff in the presentation room. A big guy like this, and he whispered in my ear, he says, "You need to add an alkaline metal." And I said, "What, you mean like lithium?" And he just like slightly smiled and then walked off, and that was it. I have no idea who he's called, you know, what it was, but he told me then I needed to add an alkaline metal. Okay, well, hopefully during the course of this presentation, which we're getting into now, I'll be able to explain why that's important. So, on the 22nd of January 2013, we did an open document. We've done many open documents where we suggested different ways, asked different people to suggest ways where you could trigger the effect or concepts. It's there, it's on the web, you can not have to rethink these things. There's a lot of work already done. And don't make the mistake of thinking that you want to do the research yourself. Start with learning from the Tesla and all of the other people in between. And there's good resources on this, like Infinite Energy website, and even Stephen Krivitz's site, New Energy Times. There's some excellent old documents on there. You can learn a lot, and you can avoid making many of the mistakes that people have made in the past. Because I can guarantee you there's been some brilliant minds, other than Pons and Fleischmann, working on this, and they've gone down a path and they found it doesn't lead anywhere. So you can learn from experience. But in that document, I suggested intuitively that microwaves might be quite important. And simply you had magnetrons in the house, so it's like a fairly affordable thing to start with. I was very annoyed to find that there was this guy called George Egli in Hungary that in 2011 was already been doing this for some time with microwaves. I didn't know that Tesla was effectively using megahertz frequencies in his carbon button. So at that point, it was the furthest point back in time of someone using these kind of energies. George Egli is extremely fascinated in a phenomenon. And it's a phenomenon that a lot of people in the Eastern Bloc are fascinated in, and it's called ball lightning. And ball lightning, in fact, I went to the conference which is held every month, on the last Thursday in the month, in the Friendship University in Moscow. It's the one of the top two theoretical universities in Russia. And Dr. Samonsenko, the head of physics there, hit me up and whatever. And they call this meeting cold nuclear transmutations and ball lightning. That's what they've called it for 20 years, right? Why would they group those two things together? Why? Now, I've only just recently found out that Tesla is one of the few people in time to have been attributed to being able to create ball lightning. So he was being able to do that with Tesla coils or some sort of evanescent waves or radiant energy or whatever. He's claimed to have done this. And I think also Pons and Fleischmann did it. They're the people we know, and I'll come on to that later. Now, this interest that they have in the Soviet Union in ball lightning, because it breaks all laws of physics, it appears to be a self-sustaining plasma that can last for a long period of time. And it appears to, when it dies, it produces a sulfurous smell. You can look in the literature. Now, if you look at, there's one recording that the Chinese did just recently, I think about 2014 or something, they were looking at lightning and looking at the spectral lines from lightning, and it just so happens in their extremely high-speed spectral camera, a ball lightning came into shot, so they got the spectral image lines from ball lightning. And the image lines that you get out of that are similar to a researcher called George Oswa. He's a Japanese guy, and he came up with a macrobiotic diet, but he also came up with the technology that Srinivasan effectively admitted that existed, that had happened in a furnace here. So what they were doing in your furnace, they had these 3 huge carbon electrodes, 14, 15 megawatts of power or something, and they were feeding it with, what was it, carbon and silicon dioxide and iron oxide.
Quartz, charcoal,
and
scrap iron.
And it was to create ferrosilicon alloy. And over 35 or 32 days or something, was it?
6 weeks, yeah.
6 weeks, they were finding 4 tons of excess metal a day. 4 tons for over 6 weeks. That was 3 extra tons of silicon and 1 extra ton of iron. Now, George Oslo had already shown that you can do this in the 50s and 60s. And this most simple experiment you can do, there's a company called Quantum Rabbit in the US. You take this is another simple experiment you can do if you've got access to an EDX machine or other mass spectrometer or something. You take a carbon crucible, a pure carbon crucible, a carbon rod, 3 12-volt batteries. You can go and find those in cars in the car lot. Not suggesting you do that. And you go bzz, 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 just in air. You don't need some fancy environment. And you should find the Osawara chain reaction products. Now, I've done a whole presentation on this. You can see it on the web. I actually showed it also in the conference in Standard. But interestingly, the products you get are quite similar to the products that you get from seeing that spectral lines from the Chinese observation of that ball lightning. So, for instance, the sulfur smell that you smell that is reported in history from a ball lightning exploding is 2 oxygens combining. So your 2 O2s combine to give sulfur 32. Yeah. That's the simplest one. If you look at with oxygen, carbon, nitrogen, carbon and oxygen, you combine these together, then you get secondary combinations. You end up with 97% or something of all of the elements in your body. Just by lightning, carbon, nitrogen and oxygen. Lena explains the birth of life. And it can also explain the death. Right, what you're seeing here is, so George Eagley had an agreement for more than 20 years, I think it is. I've been speaking to him over the last few days with the electricity board in Hungary, where he lives. And every time they would get a report of a ball lightning incident over these 20 years, they would phone him up and he would go and investigate. And the ball lightning, he's been describing this, he showed me fantastic pictures. I haven't got them with me today, it's a real shame, but I have got this video. The ball lightning can sometimes go through glass and not damage it at all. Other times it can go into the glass and leave a perfectly circle hole. But not just glass, it can go through solid walls, you know, brick or cement walls. It can actually bore a hole through and it appears the material's disappeared. He hasn't looked at the transmutations. I discussed it. I said, have you ever looked at the transmutations? And actually, no, I haven't. But this is the first in his understanding, and this is the 10th of September 2016. So, no, sorry, 10th of October 2016, very recently. It's his only recording, and the only recording he understands that's available anywhere in the world, of ball lightning being caught on camera. Now, I want you to watch the motion of this ball lightning because I'm going to show you other things later in this presentation that look very similar, that someone else did, and it was man-controlled. It's going to come in down here. The suspense. Honest. Move this out of the way because it's in the shot. Right, now this is the best point where you can see it really behaving as it's doing. Really keeping your mind's eye what you're seeing here. What the hell? Just run that from the middle again. I would really want you to hold this in your mind when we just the last bit here, when we see some videos later on. So no physics can explain this.
Explain what?
What it is.
Okay.
This ball lightning.
Okay.
Okay. What do you think?
Many people here may not be familiar with ball lightning. Really?
I don't think anyone in the world really understands it.
No, but the very fact there are such things, events, mainly seen in northern climates, mostly Russia. The Russians are fascinated. So periodically when a lightning strikes, we are all familiar with normal lightning. But in these very rare events, suddenly you find a ball at the end of a lightning. And this ball of light just moves slowly. And then Russians have been fascinated. And they thought Andrei Sakharov and other, the Heisenberg, they all thought it was fusion. That's why when the fusion phenomenon started being discussed in Russia, they always had conferences describing. So physicists have been fascinated with it. Now
because quantum mechanics cannot explain it. So this is what I want you to do, is to think, don't trust what people are telling you is the only way to think about things. It's what works for what was needing to be understood at the time. There is this thing that you've just seen, you're privileged to see it, of evidence of a phenomena that cannot be explained, right? But that is truth. That is true nature. It exists, okay? I'm going to show you something at the end of this presentation, which is truth. And what you're seeing is true nature. Now, I started studying in Lena, and I came through this journey that I'm just about to tell you, and I ended up at a particular scientist. Someone started at this other experiment down here, which is going to shock you, completely shock you, and they came all the way up to this same scientist. And this scientist, I'll come on to in a minute. So George Eagley, let's see if I can find a video of one of his reactors.
You can Google on ball lightning. There are at least 2 books which have been published of the accounts. And as I said, I myself, one of the most fascinating accounts is suddenly it enters the aircraft cabin. Plane is flying, how on earth can a piece of matter or whatever come through a closed sealed window and then fly through, it just will vanish. Sometimes it will go and fall into a bucket, and sometimes it let me not.
Just absolutely amazing. But like I say, the Chinese identified that it's the same kind of reaction. So for the first time we know, not just from anecdotal evidence, that the transmutations are occurring in the ball lightning.
Transmutation?
Yeah, because it's in air, and you can see the spectral lines of elements that are not in air normally. And at the end you get this sulfur burst. Okay? So the same things that you observe, by the way, when you're doing these sparkies. Okay, so George Eagley has looked, the surface of the sun is one temperature, it's not very hot, but the corona is extremely hot. It's like, I can't remember, it's in the hundreds of thousands of degrees or whatever, it's millions of degrees. I don't know, it's very, very hot. Who knows a nuclear physicist here? Anyone? What's the temperature of the corona of the sun?
6,000 degrees.
That's the surface.
Huh? That's the surface, I don't know.
Okay, it's much, much hotter.
Yeah.
Anyway, so he He attributes this, you can go and look it up. He attributes this to dusty fusion. And he explains this, he's done good papers and so forth. But essentially, you're getting particles, in his case in carbon, in a microwave resonant environment and in a multiply resonant environment. And as the electrons are being moved backwards and forwards, they're going into the carbon and building up 10 to the 9, he says, charge clusters in the surface. And because you're having the field shifting also, these charges are shifting to one side of the particle and then to the other. Now you can imagine 2 nanoparticles of carbon with fantastically strong electrostatic fields between them, and then in that plasma you also have ions. So the ions are accelerated. This is like a super version of the Tesla. And he based his technology on understanding Tesla. He basically, before he wanted to go into Lena, he went back to the history books. He thought, I'm not going to try and do what these people have done before without, starting from there. So, but he's taken it to the max, and he's claiming that the level of acceleration in here, because you've got microwave acceleration resonant cavity. You then have an acoustical resonant cavity, has a silicon dioxide acoustical resonant cavity with 2 tuned ports. So you get sub-frequency and ultrasonics into incredibly high phonon vibration. So that's longitudinal waves. So you've got the microwaves like this, the longitudinal waves, and then you've got surface plasmon polariton resonance on the surfaces as well. And then you've got plasma wake field acceleration. They're just starting to consider in the Large Hadron Collider. And he says that these things can accelerate and combine together. I mean, it's a pie in the sky figure, but you just need to look at the rate of transmutation. He's claiming that you can put carbon powder into this, and you get 2-3% iron out.
Okay.
Right, so this is a replication of what they're doing in that experiment, sort of. Because you've got silicon dioxide in the quartz, you've got carbon, and you're just starting with carbon. What actually happens is carbon and nitrogen, this is in air, carbon and nitrogen fuse to make aluminium. Is that right? 26, 27, 30, it's 2 carbons. 2 carbons. Is it 2 carbons? Carbon and nitrogen.
6 plus 6.
No, that's right, carbon and nitrogen. And then 2 aluminium fused to make iron. 27, 27, 54. And depending on which isotopes you're on.
There is the aluminum in this.
The aluminium forms from the carbon and nitrogen.
Oh.
And then it's
Secondary.
a secondary. Yeah. So I'm going to show you the entire experiment, and we have the plans for this reactor. So if you've got a metal workshop, we're happy to share it with you. And we have the electrical design so that you can do the electronics. And the bit I'm going to show you about this at the end ties into the whole mystery of what's going on with Lena. Here's the carbon powder. This is his pseudoscience test here. A bunch of neodymium magnets, it's not moving around.
Okay.
I said, this is not good science, even on camera, because he just poured it back in there and he could have had iron in there. I said, when we do a video, we'll make sure everything's on camera all of the time. Well, I want to do an experiment where we take this to someone who's got EDX, and we do it. They take a sample out of the fuel, they do it in the EDX, they put it back, put it in, we run it for 3 minutes, ding, give it back to them, and they take a sample and they see it's transmuted. And even let them do the whole thing themselves. So this is the quartz. You get these custom blown. They're the most expensive consumable. They're like $50 a piece. But you might find some quartz produced in India. Yeah. Because it gets such fantastic temperatures. You can do it with a normal microwave. You get a match with just light a match and let it go out so there's some smoke. Put a glass, a borosilicate glass over there. The plasma forms in your microwave. And it burns through the glass. It's great. So this is mica, and this is to get it into the resonant point in the microwave cavity. So it's a mica stand there. There's a tip for doing this. You can map the high energy areas in your microwave by getting waxed paper and putting it in the microwave on mica stands at different heights, and then you can work out in 3D where the highest energy points are in your microwave. What he put in there was a 2B carbon lead from a pencil, and he tested that to show that it's pure carbon, essentially, in silicon dioxide. And what that does is you get a difference in potential from one point to the other in the microwave field, and so it heats up the carbon until some of it vaporizes into nanoparticles, and that creates the nanoparticles for the dusty fusion. Now, while this is going on, his last investors were Swiss. This is not public knowledge until now. The Swiss asked him to make gold. Now, he told me that he believes in structural models of the nucleus. One of them is Cook's theory. Srinivasan can fill you in on that in time. And that's saying...
What do you call it? Verification or something.
There is a magnetic form of carbon, but it wouldn't form like this. So there you go. I'm going to play, whilst I'm talking about this next story about Eagly, I'm going to play you some of his other plasma videos here. So he was asked...
Is any estimate of how much energy was put in?
It's a magnetron, so he was using standard 700 or 800 watt microwaves. It uses 50% duty cycle because it only uses half the wave in the microwave. That's why you get that hum. So the actual energy delivered is about 700 watts. It's about 60-70% is the rating of the microwave, but even less is delivered into the chamber.
Okay.
So it's not a lot of power.
Create how much iron? How many grams?
2.7% of whatever you put in. And this would mean the entire building would have been vaporized if it was nuclear.
Some takeaway, so much energy for so much iron. That's what I'm looking for.
Yeah, I know. Don't try and think like that.
It doesn't consume energy, it produces energy. The carbon plus oxygen fusion reaction is exothermic. It produces 35. You have to just heat it up. The benefit of students, this original carbon arc experiment has been replicated in Bach. Way back in 1992, published in Fusion Technologies.
By Bokris, and there's some Indian people that did it as well, isn't there? Yeah.
Simultaneously, it was done in Bach, and I called up Bokris.
Yeah.
Our man is working there. Anyway, that's all. I don't want to take away from your talk, but that's all different. But it has been done. I mean, it has been published, and the fact that when you strike an arc between carbon rods, you produce ions.
There's a guy that's made a working machine, apparently, produces a lot of power, with very big, fat silicon, carbon rods. It's called Centilli. That's the name of the guy. He's another Italian. And he has a silicon-based deposit on the, I think it's the cathode, or one of the electrodes. And Parkhomov has a patent along with another Russian called Bajatov, using similar family of technology. And they claim about a 7 times gain. And the similar experiment was conducted last year in India, and they got about the same results 7 times from these arcing in water. That was an arcing in water experiment. This can produce incredibly loud noise, but the other thing is it can produce waves that you don't hear but can make you feel sick because of the intensity of the energy that's produced. But it's going out in every frequency you can possibly imagine. It both as scalar waves, as longitudinal waves, and as transverse waves. So you can see the plasma's coming out here and just melting this quartz tube here. So back to the story. That's the carbon lid. He was asked to produce gold, I understand now from a researcher in Ukraine, I think he is, a guy called Adamenko. He was using low pressure